Hello everyone, welcome back to the training and I hope you guys are doing well. So in the last class we discussed about OSPF, right? And we did a practical of multi-areas. Very good evening, just a minute and okay. So in the last class we learned how we can connect let's say area 0 with another area 1 and area 2. So we discussed how we can connect them with area 0 and can make communication between devices of these areas possible. So now we have completed the routing protocols, namely RIP, PIGRP, and OSPF. Now we are moving ahead with layer 2 technologies from today onwards. And under layer 2, we'll be discussing about VLANs, trunking protocols. And after that, we'll be discussing about BTP, STP, and Ether channels. So we will be looking into these topics in the coming days. So for today, we have VLANs and trunking protocols in our schedule. And let's quickly begin the class and learn about how VLANs work. No issues, Neeraj. We will discuss about that in the end. But first, let's focus about learning VLAN and trunking protocol. Okay. Now, when it comes to switching, VLAN is a very important part of it. And what basically VLAN does is, let's say we have a switch here. And end devices are connected to this. Let's assume that there are 6 end devices. Now, if I tell you that these PCs are configured with a network of 192.168.1.0/24 and they have the IP 1.1, 1.2, 1.3, 1.4, similarly 1.5 and 1.6. So I want you guys to answer that would they be able to communicate with each other or not? Okay, we have the answers and everyone is saying yes. Yes, they will be able to communicate because they are in same network, right? But if I tell you that, let's say this PC A and B are supposed to be used by, are assigned to, let's say, HR team. Now, I want A to be able to communicate with C, D, E, or F. And to make that work, we use VLAN. So basically, VLAN, what does VLAN do? VLAN divides the network logically and create a group. Make sense? So first of all, VLAN stands for Virtual Local Area Network. So what we are basically doing by creating a VLAN on a switch is we are creating a group so that that group cannot communicate with other present groups on the switch. Make sense? Now let's understand this with another example. So let's say we have a switch here and that switch is now connected to another switch. Let's say this is switch 1, this is switch 2, and similarly we have another switch here, switch 3, and this is connected to another switch, switch 4. Now switch 1 has user A and B, and switch 2 has C, switch 3 D, E, F. Okay, so these are the users of users who are connected to these switches, right? So now the question is that if we put them in a different VLAN, and if we put them all of these PCs in a different VLAN, so they'll not be able to communicate, right? Okay, so basically VLANs are used. So let me explain you with the same example we used before. So let's say there are 3 PCs connected. Okay, A, B, and C. Now all of these PCs are connected on the same network. So let's assume that the IP on A is 1.1, then on B it is 1.2, then on C we have 1.3. If we don't make any change in this configuration, they'll be able to communicate, right? Since they are in the same network. But the thing is that let's assume that A is from sales team and B is from marketing, and similarly C is from HR. Question to you guys, that what if we configure these PCs with some different networks? So let's give A the IP 1.1 and B 2.1, C 3.1. So now if I tell you that they will not be able to communicate, and since they are in different network, right? So what is the use of VLAN when we can use such networks, or we can do subnetting? Then why we are using VLAN here? So even if you subnet a network or just configure the devices with different network IDs, so even in that case also they will not be able to communicate with each other until and unless you configure routing for them, right? So the question is, why do we use VLAN only? Why don't we just configure them with different networks? Okay, we have some answers. Okay, no worries. Let me explain you this, why we use VLAN and not subnetting. So IP limitation is not something we can consider here, because even if you configure VLAN or not, IP is something which you have to configure on devices, right? So you have to use an IP address. You cannot avoid using IPs when you are using VLAN. Okay, so no issues. So there are some additional reasons, but one of the most important reason is, I hope you guys remember that in the initial classes when we were discussing about functioning of a switch, we discussed that how a switch learns about MAC addresses, right? So let's assume that this is a fresh topology and switch is not aware about the MAC address of A and B. So when A will try to ping or send data to B, then in that case, switch will record the MAC address of A in its MAC table. So let's assume the double A as a MAC address of A and double B as MAC address of B. Now when switch receives the packet from A, and let's just create another PC here with a MAC address double C. Now when switch will receive the packet from A, he will check the source MAC address and will add it to its MAC table. And when switch will find that, okay, the destination MAC is double B, he will check the MAC table. So since there is no entry about double B, now switch will broadcast the message on all other ports which are there except the one it received it from. So basically, what switch will do, it will broadcast the message on B and C. So on all of the ports which are connected to switch is going to broadcast the message. Now, if we look in a topology like this, here, if A tries to ping B, and if the MAC table doesn't have entry about B, so if let's say MAC table is not yet created, so it doesn't have the entry about B, so in that case, switch will broadcast the message and message will be sent to B as well as switch number 2, and from switch number 2, it will be sent to C, then after that switch 3, then to D, and similarly it will be sent over here, and from switch 4 it will be sent over E, F, and all this broadcasting will happen. And if you configure a network with different subnets, you cannot avoid this broadcasting. Why? Because this broadcasting is basically working on layer 2, right? And when we talk about subnetting, so that's a process of IP, which is a layer 3 thing. Now to avoid this packet flooding and this broadcasting of messages, we use VLAN to divide a network. So why we are not using subnetting, I hope that is clear now. So if you configure subnetting on them, they'll not be able to avoid this broadcasting, since this broadcasting is being done on layer 2 and IP is a layer 3 thing, and subnetting and all this cannot avoid such flooding. Now, if we configure VLAN, in that case, we can avoid these things. Make sense? Now, I hope you guys are clear why we are not using subnetting to divide the network and we are using VLAN. If someone have any doubt, or if you guys are not clear about anything from the explanation which I have till now explained, you can ask me. Otherwise, we are good to move ahead. So also this flooding is known as unknown unicast flooding. Okay, let's quickly have a recap of this since there is some doubt. So exactly, Abhijit. Abhijit has also tried to explain the VLAN and is absolutely correct that what basically VLAN is doing here is it is dividing the broadcast domain. So that you can like divide a network, or you can understand this by the concept of subnetting as well. So let's try to understand this again. So basically the question is, why subnetting? Oh, why VLAN and not subnetting? We can say it subnetting versus VLAN, right? Now, when we talk about switch, we know that switch maintain a MAC table. And whenever switch receives a packet, it checks the MAC table. If there is some entry, so let's say we have these PCs connected to switch and their MAC addresses are AA, BB, CC. So this is just an example. Now, if A tries to, so let's say the MAC table has the entry about AA, that okay, AA is connected on 0/1, then BB is connected on 1/1. Similarly, now switch is not aware about CC, or we can say the PCC, right? So in that case, if A tries to send some data to C, switch will check its MAC table and will find out that okay, I don't have any entry about this destination MAC address, which is CC. So I will just broadcast this packet to every port. So switch will send the packet to B and C, asking out that is there anybody with this MAC address, which is double C. Now C will reply to that yes, I am here with the MAC address double C. And now switch, since the switch has the MAC address of double C as source MAC address, now switch will add entry about C as well. Is it clear till now how MAC address is formed? MAC table is formed. So we can conclude that switch only trusts source MAC. So the time C replies that, hey there, I am the one who has a MAC address of double C. At that time, source MAC will be double C, right? Since the source of packet is PCC. And at that time only, switch will add double C to its MAC table. Now, if we configure this network, okay, let me just quickly erase this. Now, if we configure this whole network using subnetting, or we can say using different subnets. So let's say we configured A and B as 1.1 and 1.2, then C as 2.1, D as 3.1, F as 4.1, and E as 4.2. So in this case also, these PCs cannot communicate with each other, right? Like they can communicate within their group, but they cannot communicate with a PC from different network, right? But still, if A tries to send some data to B, and if switch 1 is not aware about MAC address of B, so let's say there is no entry about MAC address of B, in that case, what switch will do? Switch will broadcast the message and it will send it to B. Similarly, it will send it to switch number 2. Now when switch 2 will receive it, it will send it to C and to switch 3. And similarly, switch 3 will send it over here, and then again switch 4 will send it to E and F. Now to avoid all this unicast flooding, which is known as unknown unicast flooding, we use VLANs. We use VLANs to basically divide the network. So now even if you configure the whole topology with the same network, let's say 1.1, 1.2, then after that 1.3, 1.4, and similarly 1.5 and 6, even in that case also, we can avoid this flooding using VLANs. I hope it is clear now. Awesome. So now there's one more thing you can keep a note about. So if we talk about basic understanding of VLAN, so VLAN is basically dividing the network logically, right? It divides the network logically, and we can say it create logical broadcast domains. All this can work using a switch and host. Now we will look into packet tracer and we'll try to configure some VLANs on a switch. So here we have our packet tracer. Okay, so we are going to add a switch first of all. And with that, we will connect some end devices. Okay, couple of pieces for. Okay, let's quickly try understanding with the same example which we have used in the explanation. So we are going to configure these pieces in different VLANs. And for that, we need to connect them through the cable. So I am connecting them all with the switch. And now we will configure them with the IP address. So I go to desktop IP configuration. let's add a static IP. 192.168.1.1. Press tab, you get the subnet mask. 192.168.2. Tab. So we are keeping them all in the same network, which is 192.168.1.0. So you don't have to like configure the gateway, since we are not going to share data over different network. So we don't need a router here. Desktop IP configuration, then 192.168.6. Okay. So now, if you try pinging from PC 0 to, let's say, PC 4, so it's going successful, which means that these PCs are connected together, right? They are in the same network and they can communicate with each other. So if you try pinging from any host to any host, that will go successful. But as our requirement says that we want these two in sales team and these two in marketing team, then these two in HR team. We don't want these teams to communicate with each other. We just want their host to be able to communicate with each other, but not with a host of different team, right? So we will try to make that possible using VLANs. So this is sales team. And here we have our marketing team. Now, if you hover your mouse over your switch, you will get some details about your ports which are there on the switch. So if you look at the list and if you look at the third part of the list, which is VLAN, so it tells you that every port is in VLAN number 1, right? So basically, by default, every port is in VLAN 1, and we can call VLAN 1 as a default VLAN. So every device which is connected to switch is by default in VLAN number 1. I hope that's clear to you all. Now what we are going to do is we will try moving, like if we talk about PC0 and PC1, we know that they are connected on FA01 and FA02. So what we are going to do, we will try moving FA01 and FA02 from VLAN number 1 to a different VLAN, so that they cannot communicate with devices which are there in VLAN 1, or let's say, or in any other VLAN, right? So for that, we have to create a VLAN, right? For to first of all, we have to like get one more additional VLAN, right? Instead of one, we have to create one more VLAN in which we can configure FA01 and FA02. We will go to switch, we will move to CLI, and enable conf t. You can change the name using the same command which we use for router. Host name, let's keep it as SW1. Now, to create a VLAN, you just have to type VLAN, and if you press question mark after that, you get a range. The range is there from 1 to 4094. Now, if we talk about this range, then 1 is there for, as we just have discussed, number 1 is the default VLAN, Then from 2 to 1001, therefore standard VLANs. This for normal uses, we have 1002 to 1005. This range is reserved VLANs, and that these are not for use. Now from 1006 to 4094, range is therefore extended VLAN. And these are used for voice and wireless configurations. Basically, the range which we are going to use is from VLAN number 2 to VLAN number 1001, and we can say that rest of the ranges are not there for our use and will not be looking into them. So that's the very first thing which is clear. I hope which is clear to you all, that the default VLAN is VLAN number 1, and in order to make VLAN configuration possible, you have to first create some VLANs, then you have to assign the ports to that VLAN. So now we will go to the CLI. So we know that we can use a VLAN number out of the range of 2 to 1001, right? So we are going to use 10, and after that you press enter. Now you can name this by running the command name space the name of the VLAN. So let's name it as sales only. And that's done. So you have successfully created the very first VLAN, which is VLAN number 10, and you have named it as sales. So if you take an exit from this VLAN config mode and again take an exit, now you are in enable mode, right? So now if you run a command show VLAN brief, you will get the details about VLANs. So we have the very first VLAN, VLAN number 1, which is default, and as of now, all of the ports which are there from FA01 to FA024, and after that 2 of the gigabit Ethernet ports. So basically all of the ports which are there on the switch are currently a part of VLAN number 1, which is the default VLAN, right? But if we look down, we see a VLAN number 10, which is there with the name of sales. So we have successfully created the VLAN. Now the task is to assign FA01 and FA02 to VLAN number 10, which is sales, right? But before that, let's quickly create other 2 VLANs as well. And we will type VLAN. Let's take 20 for marketing. And if we type name marketing. So that's one more VLAN we have created successfully. We will take an exit. Now again create one more VLAN for the HR department, VLAN number 30, HR, and that's all. Now if we look at our VLAN brief, we can see that there are now 3 additional VLANs. The first one we have sales, then we have marketing, then we have HR. Now the last task is, okay, so we will look into that, Jaspal, don't worry. Let me complete myself first. So as of now, all of the ports are part of VLAN number 1, which is the default VLAN, right? But we have to make FA01 and FA02 part of VLAN number 10, which is there for sales. Similarly, FA03 and FA04 we have to make them a part of VLAN number 20, which we have created for marketing. And these two will be a part of VLAN 30, which is therefore HR department. Now let's understand how we can assign the ports to these VLANs. So what we have to do is we will go to interface, which is interface FA01. Then you have to run the command switch port access. After that, you have to type the number VLAN, the number of the VLAN which you want to assign this port to. So FA01 is there for VLAN number 10, right? So we will type 10 and press enter. Similarly, we will take an exit from FA01 and we will go to interface FA02. Now we will run the command switch port access VLAN 10. Exit. Do you guys understand till now? So we have, as of now, we have created the VLANs and we have assigned 2 ports to VLAN number 10. Okay, great. So Jaspal, we will look into the ranges. Don't worry. So the basic understanding is we can use only from 2 to 1001. Like you can create a VLAN from VLAN number 2 to VLAN number 1001. Sure. I will write the configurations till the time you can like focus on the class. So I hope everything is clear till now. And now if we take an exit from the config mode and look into our show VLAN brief, now we can see that from default FA01 and FA02 is now moved to VLAN number 10, which is for sales successfully, right? Yes, we will look into that as well. We will understand how range works. So FA01 and FA02 is successfully moved to the sales VLAN. Is it clear now? Now we will move the rest of the ports to VLAN 20 and VLAN 30. So when we look at VLAN number 20, we have FA03 and FA04 in that. We'll go to config mode, and so there's one more question. So if you have 32 ports, then you are not going to like each and every interface one by one and assign the particular VLAN which is there for that port, right? In that case, what you use is you use the command interface range. So it will look like something this interface range, and after that you can type the range. So we just have to use FA03 and FA04. So we will type FA0/3, then after that press a dash and 04. And once you click enter, you will see that now you are in the interface range configuration mode. Great. So whatever changes you will make to these interfaces now, that will apply to FA03 as well as FA04. So we will just quickly run the command switch port access. Since they are part of marketing VLAN and we have assigned VLAN 20 for that, we will run the command, press enter, and that's all. Take an exit. Now we are left with the last range, which is for FA05 and 6. We'll type interface range FA056, press enter, switch port, access. Make sense? Yes, in that case, if you have some different ranges, or let's say you have divided ranges, so you can use a comma between them. So it will look like something this FA01 to let's say 5. Then after that you can put a comma and the next range will go from here. So let's say FA07 to 10. or anything which whatever ranges you want. So I hope till now it is clear that how you can select a range, and after that you just have to assign that range to a particular VLAN. Now if we take exit from these modes and check the VLAN table or the VLAN information which is there on switch. So show VLAN brief. Now you will find out that in the default VLAN we have the rest of the ports, and in the sales we have FE01 and FE02. Then for marketing we have FE03 and 4, and similarly for HR we have FE05 and 6. Now if you try making communication between them, if you try pinging from PC0 to PC1, that will go successful. However, if you try pinging from PC0 to PC5, it says failed. Similarly, if you try out any host of different VLAN to ping any host from different VLAN, that will go failed. Can you see this? It's failed. Even if you retry this, it will go fail because they are part of different VLANs. So this was configuration of VLAN. You guys can take your time and try this out. And meanwhile, I'm writing the commands here for those who missed on the commands. So first of all, you have to enable the switch, then you enter the configuration mode. Then you have to create VLANs. So let's say VLAN 10, and you can name it by running the command name space the name you want to give. Take an exit, create the next VLAN you want. Name. Take an exit. 30. Then here we go. After this, you have to assign the ports to these VLANs. So we'll go from interface range FA0/122, and we'll run the command switch port access VLAN. Now interface range /3 to 4. The command switch port access and the last range interface range FA05 to 6. For that we use, we have a question that how we can make communication between these VLANs. So for that we use inter-VLAN routing, and that's a different topic. We'll be looking into that as well in the coming days. And will be switch port access VLAN 30 and take an exit. That's all. These are the commands for VLAN configuration. Let me know once you are done with the practical. I hope everyone is done with the practical and they were able to communicate, create VLANs. Now we are going to try something known as trunking, and for that I'm going to switch let's move this topology a little left. Okay, so there's a question here, no router connecting. Yes, we haven't used any router in the topology because we have just used the same network, right? So the main functioning of router is to make communication between different networks possible. So since there is no other network which we have used here, so we just use the switch. Now we will take another switch here and of n devices. So basically we are just creating another topology similar to the one which we have configured. Now let's connect them. And once they are connected over the cable, we are good to configure IP address. So we'll keep them in the same network, which is 192.168.1.0. Let's assign the IP 1.7 on PC number 6 and 192.168.1.8 on this PC. And here we go. We have successfully configured the IP address on all of them. And since they are not in any different VLANs and all are in VLAN number 1, which is default VLAN, so they'll be able to communicate with each other. As you can see, the packet goes successfully. Now, what we are going to do here is we will create again the sales VLAN, the marketing VLAN, and the HR VLAN. So let's quickly go to the configurations of them. So we have FA01 and 2 in the sales department, which is going to be VLAN number 10. Then we have marketing, which will be VLAN number 20. And the department, which will be VLAN number 30. So let's quickly go to the CLI of switch and create these VLANs. Enable T as switch 2. Now name it as sales. Take an exit. And after this, we will create another VLAN, VLAN number 20, and name it as marketing. The last one, VLAN 30, name it as HR. We have successfully created all the VLANs, and if we look at the VLAN information, we can see that all of our VLANs are being listed in the details. Now we will quickly assign places on these VLANs, and we have 1, 2 on VLAN 10, then 3, 4 on VLAN 20, then 5, 6 on VLAN 30. We'll go to interface range FA0/1 to 2 and run the command switch port access VLAN. Now the next range, interface range FA0/3 to 4 and switch VLAN 20. Now the last range, which is interface range FA0/5 to 6 and switch port access VLAN 30. So we have successfully assigned the ports to these VLANs. At the details, we can see that 0, 1 and 0, 2 are in sales. Similarly, 3 and 4 are in marketing and 5 and 6 are in HR department, right? Now, if we connect these two switches together, if we connect them together, so can PC1 of VLAN 10 from this switch communicate with PC6 of VLAN 10, which is there on the switch number 2. So let's try pinging them and see if they are able to communicate or not. So I'm pinging from PC0 to PC number 6. So they both are in same VLAN, but still the packet goes failed and packet is not reaching the destination. And even if you retry it, it will go failed. Why? Now we have to understand this. Now, if we look at FA07, which is connecting switch 1 and 2, so we will find that FA07 of these switches are still a part of VLAN number 1, right? Make sense? So, a VLAN number 1 cannot take the communication from VLAN number 10. I hope you guys are able to understand what I'm trying to convey. So since FA07 is a part of VLAN 10, it cannot take the communication from VLAN number 10, right? So we have to make some configuration for FA07 so that it can make these communications possible. Now for that, you have to understand something called as modes. So basically there are two types of. The first one is access port. And if we talk about access ports are part of one VLAN. Like FA01, FA02. So these are access ports. And the other category is trunk ports. Now, these ports are part of no VLAN, but communicate VLANs. Make sense? So basically, there are two types of ports. The first one is access port. Then the other one we have is trunk port. So trunk ports are those which are part of no VLAN. I mean, like it is not a part of VLAN 1, 2, 3 or whatever you make, but still it can communicate with VLANs which are there on the switch. So I hope that's clear to you all. And now what we are going to do is we will create FA07 as a trunk port. So we will convert it from access port to a trunk port so that it can carry communication or it can carry packets of VLAN 10, 20, 30 from this switch to this switch. Const will go to interface FA07 and we have to run a command switch port mode trunk. Then you have to press enter. Now this port will restart. Okay, so we made a mistake. We have configured FA01 as the trunk port. Yes. So to fix that, you can like go to interface FA01 and run the command switch port mode access. So just as we discussed that there are two types of modes which are there. So if you even press the question mark, you will see access, dynamic and trunk. So we don't have to look into dynamic as of now, and we can use access and trunk. So we will put it back to the access mode. Once you press enter, the port will restart. As you can see, it will restart and will get back to the access mode. Now we'll put interface FA07, which is supposed to be the trunk port, to the trunk category. So interface FA07/7, and we will run the command switch port mode trunk. Press enter. Similarly, go to switch number 2 and make the FA07 as trunk port. So interface FA0/7 switch port mode trunk. To run this command, the port will restart, and to avoid the wait time, you can skip it. Now, if you hover your mouse over your switch, you will find out that FA07 is now part of no VLAN, right? There is double dash, double hyphen in the column of VLAN. So this represents that it's now a trunk port. Now, if you try pinging from PC0 of this switch to PC6, it goes successful, right? Similarly, if you try pinging from a PC of marketing department to a PC of marketing department on another switch, which is, let's say, PC9, so it goes successful. So that's something known as trunking protocol. And still, if you try pinging from one VLAN to another VLAN, it is not going to be successful. It's going to be failed. So that was trunking, and I hope the configurations are clear to you all. I'm going to write the command. So all you have to do is replicate so these are your tasks, right? Which you have to perform at your end. Replicate the topology. You have to connect the switch. I shall say switches together. Make the port connecting switches the command which we will be using to create that port, a trunk port, is we will go to interface configuration mode. Let's say you also get FA07 as your trunk port, and after that you have to run the command switch port mode trunk. That's all. So Swati, the thing is that we have in this example also we have configured the PCs with same network, right? We have configured IP from 192.168.1.0 only, and we have different VLANs on them. So I hope that answers your question. We have selected the same example. And when it comes to different network, so that's not going to be possible since the networks are different. So you have to run routing, and only after configuring routing on a router, you can make communication between different networks possible. So I'm keeping the commands on the screen, and you guys can perform this practical. Once you are done, you can put it in the chat. So you have your time. Okay, so I hope everyone is done with the practical, and we have some. Okay, so great. I really like when you guys help each other in the chat, and so we have a task for today. What you can try now is try making another network with a different switch, let's say a third switch, and create some VLANs on that and connect them with these two switches, and like try making communication between them, between the devices of that VLANs. So that's your task for today. And so that was all we had for today's session. We were scheduled with the discussion of VLANs and trunking protocol. So we will wrap the class a little early today as we are done with it. That was all for today. Thank you guys for tuning in, and let's meet tomorrow at the same time. Keep practicing and try making these topologies a little more complex and see what you can get out of them. Great. Bye guys.